Welcome to another China Daily Roundtable event. Today we're here to discuss the future of artificial intelligence in manufacturing industries. I'm DJ Clark and I'm talking to you from Hong Kong, but our guests, our panelists and our keynote speakers today are spread out all over Asia. I'm going to give them an introduction in full when it comes to their turn to speaking, but let me quickly say who we have. We're going to start with three keynote addresses. First from Dr. Neil O'Connor, who is Professor and Head of Department of Accounting at Monash University in Malaysia. And then we're going to move over to Dr. Masahiro Nakamura, sorry about my pronunciation there, CEO of Lexar Research. And then finally to Dr. Wang Yu, the Research Fellow at the College of Intelligence and Computing in Tianjin University. And I should point out here that Tianjin Municipal People's Government Information Office is the co-sponsor of this event today. Now, after that, we've got some media interest. So we're going to have some media speakers in a shorter sort of panel discussion, but everyone will be joining in actually for the panel. We've got Miss Lily Gao, reporter from Vietnam News, Miss Grace Chai, the senior reporter and business news from China Daily Asia Pacific here, and Dr. Umar Saif, the Chief Digital Officer at Jiang Media Group. Now, as I said, I'll give you more information on them. If you want to go onto the website, cdroundtable.com, that's where you're going to find all the information on all the speakers. I'm not going to have time to go through everyone. If you have any questions, please let us know down below in the comments here on the Zoom. We will get to them later. I should also mention, of course, my co-moderator, Mr. Kun Pana. Kun Pana, of course, coming from the Asian News Network, the Executive Director of the Asian News Network, coming from Bangkok. Thank you for joining us, Pana.
Yeah. Good afternoon. Good afternoon.
Pana, you're going to be asking some questions later on.
Yes,
but I want to kick this off as soon as possible. So let's get going with Dr. O'Connor, Dr. Neil O'Connor, Professor and Head of Department Accounting at Monash University. Let me give you a little bit more. Neil has spent over 20 years in Hong Kong, where he researched the modernization process of Chinese firms, examining issues such as performance, measurements, order qualification, and trust. Now, as I said, on the website, there's a lot longer bios for everyone here if you want to go on and check who our key speakers are. So I'm going to hand it over to you, Dr. O'Connor, to start us off. And I think you're going to take control of our Zoom so that you can present your presentation from where you are. Your microphone's not on at the moment. We're not getting sound coming through. Is that right?
I'm all good here.
You're right. Okay, we've got you.
That's good.
Let's go. Yeah.
Excellent. Thank you, DJ. And I just want to reach out to the audience because what's happening with the announcements and the government initiatives in China, which is really, really beneficial for the long-term development, and you go on Industry 4.0 with the Made in China 2025, but now we're talking about AI and today's topic, AI and manufacturing. How does that apply to the average manufacturer in China, in Asia today? And these are some of the issues I want to address today, because often we think about a lot of the government initiatives, but what actually drives innovation in the long term is also a mix of collaboration and owner mindset, and also VC capital has spent a lot of money on startups, innovations over the last decade, especially in this region. And so I want to talk about the challenges for AI for the ordinary manufacturer and giving you real examples of that. I'm going to skip over what is AI. Well, I assume that we all have a good idea of what AI is and how it applies to the automation pyramid for the factory. And for a lot of factories in Asia, they don't always have these multiple layers of ERP systems and manufacturing execution systems and SCADA and PLC and sensors at the production process level. A lot of them are much more basic than that. So how do you actually go to the next level? And next level, meaning the following: how do we go from a documented process to continuous improvement to digitization? And that's what I want to talk about, because many factories that I talk to and visit as part of auditing factories are at the stage of documented process or continuous improvement levels and have not reached the digitization. And after that, the opportunity to actually use AI or exploit AI to solve various problems in the manufacturing. The big challenge I see in my visits of factories in the region, and visited hundreds of them, is the owner mindset. Many owners don't have a strategic vision for making the factory world-class, for making a world-class product. It's gone from product to product and very much not necessarily focused on developing the talent and the skills in the organization. And this owner mindset is a big thing that we're going to talk about later on the panel. What I want to show you is some areas where I've seen factories where documented processes can be digitalized, and other areas where actual processes can be used to actually feed into an AI algorithm. What I want to take you through is about 6 examples, and to give you full understanding of a comparison, these 2 factories are basically making the same product. And you'll see that the one on the top has actually advanced further in terms of continuous improvement towards the digitalization end. The factory at the bottom, even though you're seeing computer-aided design on the PC here, the actual process is much more at the documentation process, and they have much more room for continuous improvement to undertake. And as you can see, the assembly lines are totally different, but they're basically making the same product, although the product, that the factory is making on the top is definitely sold for 4 times, 5 times more than the product in the bottom. And so I give advice to these factories to think about how can they document more. At the documentation stage, they are documenting where they have quality problems, but to get to the continuous improvement and digitalization, we want to start to digitalize this type of information in the factory. Let's have a look at another product, and let's just pick on one product. And I'm just going to turn down the volume here because the machines are quite loud when you go into factories. But here are 2 factories making exactly the same product, hoverboards. And the one at the bottom is basically more of a workshop where every operator there is going through the 90 steps to make that hoverboard themselves. Whereas at the top, we've got this Henry Ford type idea where, okay, let's just have a process where every operator just does 2 steps. And so if there's any sickness in an operator, you can replace that operator overnight and keep the factory throughput going. And so these are ideas of how you can continuously improve on a physical sense. But of course, then once you go to the one at the top, you can go to the next stage and start to digitalize different phases in the assembly line. And then often, the digitalization leads to data collection and opportunity to use AI. Let's have a look at where AI is definitely can help in factories. And this is definitely on the materials inspection. And so we have exactly the same battery being received by 2 factories. And the one on the bottom is the battery pack, and they're just accepting it as it is, no testing. Whereas the one on the top is actually receiving the individual cells, 20 of them, that go into the 4.4 amp hour battery pack that goes in the hoverboard. And here we have a machine and collecting data as it's actually testing the individual cells that are coming into the factory. So this is the starting point of a digitalization process that we're seeing in the factory at the top. All right, so what else can we learn about where AI can be useful? Well, it's possible that we want to collect data on the quality gates. And what we see in factories, this is making car audio, a lot of the documentation are paper-based like this. And so the next stage, we want to get that factory to move to digitalize every instance of these quality control problems. Why do you want to do that? Because you want data over time, so you see common problems that are occurring, so you can actually invest more time and effort to fix certain parts of the assembly line. Here, we're trying to fix the screwing in area of this assembly line, and then later on we go around to another part where we've got the soldering area, where two parts where we've identified quality problems. And this is common in a lot of factories where they find problems, but they don't follow up to see how they can make the process better, or even making the ergonomics of the operator better, so there's less variation in how they're aligning their hands and putting the assembly together. It doesn't have to be a robot that AI is applied to. You can apply AI and digitalization to manual assembly lines if you're collecting the data. And so here we have the operator here, where the soldering base of the IC PCB board is actually moving as he's soldering. Creates lots of variability, creates lots of problems. And these are things that I talk to factory managers about. Attention to detail, so we can actually spend more time to document other aspects of the detail in the factory, especially keeping things clean. Like how could you digitalize or even use AI if you're going to have an open window and allow dust to go into the room? It's not just enough to just think about collecting data, but you still need to move to a continuous improvement stage like we have in the factory above. And here we have a clean room inside a clean room, manufacturing of smartphones, kind of much higher end technology. And yes, there are no robots there. It's still manual, but this manual robot, it doesn't matter when we want to apply AI to help in a factory to improve its operations. Now we have operator at the bottom, using the smartphone while they're operating. So there are obvious areas where factories are in the documentation or continuous improvement stage that can be fixed even before we digitalize. And I'm not here to run down factories, because I actually go into the factories to give pro bono advice to help them improve their operations. And I've been doing that for several years now. Here we have the burn-in room. This is another opportunity to collect data and to digitalize the data for possible AI use. Here we have it's manually collected, but you can automate this burn-in process. And this is probably a very critical quality gate that we want to see in factories, because this is the last point of testing before the actual product actually goes out and is shipped to the customer. And so we can digitalize this process as well. All right, so what have I learned by visiting the average factory? Don't say normal, workshops and SME factories in China, in Southeast Asia, in the region, is that materials received in QC is often neglected. And that's at one point where you can actually collect data and digitalize that data area. The burn-in room is another point where we can collect data and digitalize it. And also the rejects or quality gate area at various parts of the assembly line. So, as a takeaway for owners out there of factories, because we want to speak and actually help to educate factories out there, is that we want to try and improve the transparency of your operations in the customer's eyes, because we've got border closures or even no border closures. It's a priority in customers' minds to have more transparency over the factory that they are buying the product from. And so an example of how you can actually digitize, even when you have a labor intensive process, is something like what Pivot 88 does. I don't work for them. I'm not promoting them, but this is a good example of this third-party provider that provides tablets that go into the assembly line already built for you to actually, for factory owners to actually input data of exactly like the assembly lines I've just showed you in the videos. Another example of steps that factory owners can take is to get a factory audit and actually find out where are you in terms of maybe international standards, or maybe in terms of standards in your province is fine. I've analyzed through my own data analytics over 500 factory audits working with a third-party provider, and we find that there's a whole distribution of outcomes of factory audits, leading from 30 out of 100 to over 90 out of 100 across a whole range of provinces. So factories aren't there yet in terms of a factory audit. Why does a factory audit matter? Well, what I've found is I've matched factory audits with product audits in over 300 combinations and found that having a good factory audit outcome is significantly leads or significantly predicts a better product audit outcome. And that product audit outcome as a pass is exactly the outcome you want as a factory, because that means a happy customer in many cases. So just summarizing, there are obviously benefits of Industry 4.0 and AI industries, but it's industry specific. The automotive industry is actually leading the field in this area, with the major auto manufacturers around the world and in China adopting Industry 4.0 and AI already. And they are able to do that because it's large volume and automotive systems. And so you're collecting lots and lots of data, which makes it amenable to AI algorithms and machine learning and deep learning and so forth. There are obviously obvious opportunities being grabbed by industry players, and that is predictive maintenance, defect detection, yield output, inventory parts optimization. But for Asian manufacturers, and I say manufacturers in this region, focus on continuous improvement and trying to digitalize different areas where you are collecting data. Just like in the assembly line I showed you, collecting the quality data, the quality gates, digitize that. We're not there yet, but these are things that we can start to digitalize. Future steps, start by measuring more. Learn from third parties like Pivot 88, like factory third-party auditors. Get a factory auditor to come into your factory. You pay $400, $500 for one day. They do a full audit of the factory and give you ideas for areas you can improve. And finally, learn from OEMs in the developed countries. Some of the factories that I've visited that seem to have better systems in place told me that their major customer was a major brand name manufacturer from Japan, from Korea, from the USA, and from Europe. Obviously, they have actually learnt from these OEMs. Otherwise, the OEM wouldn't have contracted with the factory. So that's all I want to say. I want to start off with a practical note. AI is very important. It is the future, but we've got to actually close the gap from where I see a lot of factories today at the documentation and the continuous improvement stage. We need a lot more effort to move to the next stage of digitalizing so we can start to capitalize on the opportunities that AI brings us. Thank you.
All right, we're going to move on with the keynote speakers in order to get through. Before we start the questions, as I said before, if you have a question for any of our speakers today, please drop a note into the Zoom chat and we will try and pick it up later on. Our next speaker is coming to us actually from a recorded speaking that he is still going to try and join us later on to take some of the questions, but unfortunately couldn't make it at the very start because he has another commitment. This is Dr. Masahiro Nakamura, an inventor and CEO of Lexar Research. Dr. Nakamura is currently the President and Chief Executive Officer of Lexar Research, which was established by him in 1993. His founded original products include the GP4 Virtual Factory Line Simulator, the GD Findi MS cloud-based production simulation system, and GD Findi PVDO simulation AI engine for optimization. He received the 4th Manufacturing Japan Grand Award from the Minister of Economy, Trade and Industry Prize. He also received a finalist of LOT Acceleration Lab selection at the METI 2017. Can we play the recording? And as I said, we will hopefully pick him up later, or he'll be able to join us a bit later for the Q&A.
Good afternoon, ladies and gentlemen. I'm Dr. Masahiro Nakamura, CEO of the Lexar Research Company in Japan. First of all, it is my pleasure to give you my presentation as a keynote speaker. I'm a researcher and an inventor for a long time in the field of recognition, the simulation, and the virtual reality technology. Also developing our original software products for production design and optimization. As you know, recently we are facing to the AI technologies for manufacturing, but there are different difficulties in production process or production resource management. In this point of view, I have developed the new type of AI technology we call the deep thinking for optimization on the cyber physical system. Today, I would like to show you this concept as the alternative approach from the deep learning or machine learning as a new AI in manufacturing. I'd like to start my talk by the philosophy, because the technology is closely connected to philosophy. I guess you know many philosophers, and they are divided into two parts. The Aristotle and Plato as the counterpart, and Heidegger and versus Kant. Newton versus Einstein are in the same position. Upon considering this matter in AI technology, we can address the deep learning in the stream of positivism, because it is a kind of inductive approach. As you know, the learning AI is depend on past, and this approach has a certain meaning, but this approach requires the past big data. It is effective for predictive maintenance, but it is not fit to production process design, production scheduling, or production resource management. I propose the deep thinking as the rationalism approach. In other words, the abduction approach with the data model simulation. The deep thinking is depend on the enumeration method of the for the solution space by executing the massive simulation cluster. The model-based production simulation will be the key for the optimization as AI in manufacturing. We are trying to apply the technology to cyber physical system. Okay, I will show you the cyber physical system with the deep thinking concept and the application by a short video. Let's see together. As you know, the cyberspace and the physical space is connected to each other in CPS. To be done this, we utilize our own data model as the basic fundamental description of production system. Once the data model is created, optimization AI with the concept of deep thinking would train this data to be the best practice. After optimization, reflected to practical physical space. And such a data circulation will enhance the production knowledge from the expert. Utilizing this system, we have the many experience in manufacturing, factory design, also the layout design, and equipment investment. Also, intelligent logistics design can be done with this CPS system. Not only planning, daily production operation work can be applied. This case shows automation of work organization design or planning. Okay, this case shows the management of global production for several factories in worldwide. Okay, this CPS system will autonomously and continuously optimize the cyber system. Cyber physical operations. Okay, so here I show you the briefly new AI concept and the technologies in manufacturing. I would like to grow up this technology to contribute the manufacturing in Asia. I hope this symposium will proceed and complete fruit-free. Thank you very much for your listening today.
Thank you very much, Dr. Nakamura, there speaking. As I said, a recorded speech, but we are very much hoping that he's going to be able to join us later. Now I'm going to move over to Tianjin. Dr. Wang Yu, the research fellow at the College of Intelligence and Computing at Tianjin University. Wang Yu is currently a research fellow at the College of Intelligence and Computing of Tianjin. He was an outstanding visiting scholar of University of Waterloo in Canada and the member of the Chinese Society of Artificial Intelligence Committee on Granular Computing and Knowledge Discovery. Dr. Yu, over to you for your presentation.
Okay, thank you, DJ. Can you see the screen?
Oh, we can, yes.
Yeah, okay, thank you, I'm good. Hi everyone, I'm Wang Yu from the College of Intelligence and Computing of Tianjin University and the Tianjin Key Laboratory of Machine Learning. I'm very happy to be here today to talk about intelligent manufacturing. And my theme is artificial intelligence and intelligent manufacturing in Tianjin. One of our main topics today is intelligent manufacturing. But why we hope to upgrade the traditional manufacturing to intelligent manufacturing, to comprehensively understand the reason, it is essential for us to understand what is intelligent or intelligence first. Intelligence has become a buzzword in recent years, such as artificial intelligence. So artificial intelligence is a system that uses digital computers to simulate, extend, and expand the human intelligence and perceive the environment, acquire knowledge, and use such knowledge to obtain the best results. In other words, artificial intelligence is to use the past knowledge and data to discover rules in future scenarios. Among various techniques, machine learning and data mining are the two best known and widely used techniques in artificial intelligence. Artificial intelligence has today fully penetrated people's lives and their work. And it is very widely used in many fields, including medical treatment, agriculture, government operations, entertainment, retail, transportation, finance, and of course, manufacturing. We can see that in the figure, manufacturing has the largest market capacity. As a result, intelligent manufacturing has drawn a huge attention. As we know, all the countries all over the world now attach great importance to artificial intelligence, and China is no exception. In July 2017, the State Council unveiled a development plan of new generation of artificial intelligence and raising artificial intelligence to a strategic national level and making every effort to promote its development. To fully support the development of artificial intelligence, China has cultivated local talents and brought in talents from all over the world. Consequently, the number of patent applications for artificial intelligence has exceeded 37% of the global total, and the total number of papers published is among the top 3 worldwide. At the same time, Shenwei type light and Tianhe series supercomputers have been created to provide sufficient computing power support for the development of artificial intelligence algorithms and technologies. The core artificial intelligence industry has reached almost 150 billion yuan. At present, China's AI technology and industrial competitiveness is at the international level. Now, let me talk about manufacturing. We know as the COVID-19 pandemic began its rage around the world last year, and of course this year, almost every industry was in severe difficulties, particularly those that rely heavily on manufacturing, right? Because in order to control the pandemic, the government limited the number of people involved in manufacturing. So the COVID-19 is both a huge public health crisis and a global economic crisis. However, in Chinese, crisis means both danger and opportunity. That is to say, there's both danger and opportunity in such a situation. Although all sectors of society, including governments and enterprises, have suffered huge loss and pain due to the pandemic, they realize the importance of artificial intelligence and intelligent manufacturing. They understand that intelligent manufacturing, which can reduce the big need for large number of people and bring efficient automatic production, is the future of the manufacturing industry. Take Tianjin, for example. Through questionnaires sent to 472 enterprises in the city last year, it was found that generally they are paying more attention to intelligent manufacturing. And more than 45% of the enterprises have overall planning and production planning for intelligent manufacturing, and more than 65% of them have completed or are carrying out standard implementation of the integrated management system. Such changes both attribute to the pandemic and the support by the government. As an important industrial and manufacturing city in northern China since modern times, Tianjin considers intelligent manufacturing as a rare opportunity for economic development. Under the country's 14th five-year plan, and it is just right now, and Tianjin will lay emphasis on developing the manufacturing sector, especially intelligent manufacturing. And Tianjin comprehensively enhanced the core competitiveness of nationally advanced manufacturing R&D base, and enhanced the leading force of intelligent technology industry, also promote deeper integration of the internet, big data, Internet of Things, artificial intelligence, blockchain, and other real economics and many real-world applications. So we have every reason to believe that Tianjin and the nation will soon enter an intelligent manufacturing era, and of course, a very promising future. Okay, that's my talk about the intelligent manufacturing. Thank you.
Very much, Dr. Yu. Now, we're going to move now on to our panelists, after which we'll be able to start the Q&A. We have three reporters who are going to talk to us. We're going to start off with Miss Lily Gao, who's a reporter at Vietnam News. Ms. Lily Gao is responsible for local financial, market and economic stories for website and newspaper publications. She received 2 awards for video reports and articles covering the COVID-19 situation in Vietnam, and the National External Information Awards, organized by the Steering Committee on External Information, the Party Central Committee's Commission for Publicity and Information and Vietnam Television. Ms. Gao, can I get you to give us your thoughts on this subject?
Hello?
Hello. You're coming. We seem to have lost your audio for a second. Let me see if we can get that back.
Hello?
Okay.
Can you hear me now?
You are
Yeah.
back now. Yes,
Hello.
we can hear you.
Yeah, it's good. Good afternoon, everyone. So my name is Lily. I'm a reporter from Vietnam News. So today I will give a brief introduction about the technology, using technology in manufacturing industry in Vietnam. So as we all know, that technology is now the key for the successful for every economy. And in Vietnam, it has a huge impact for the industry sector. We have seen a huge improvement in electronic, mechanical engineering, electronic components, and automotive industry enterprises, especially FDI firms, have witnessed soaring in production capacities and revenues thanks to the application of the automation technology and the use of the techniques and robotics. And I think that you all may heard about the Vietnamese automaker VinFast. It's quite famous recently. And it's a typical example for the tech application in manufacturing. In the late 2019, it opened the automobile manufacturing factory, which equipped with the full modern technology and robotics. It has become a special landmark with a turning point in the country auto industry, affirming that Vietnam has really produced and mastered the core part of the auto industry, and of course surpassing the mere processing and assembly. And since that opening, it has achieved some very successful achievement. In the last January of this year, is introduced its first 3 self-driving electronic models, which is claims use AI as well as another modern features. The model will be ready for commercial sales in the late 2021 and early 2022. Also in March is introduced is electrical car model, and also open for the for placing order on its website and on showroom and dealers in Vietnam. However, if we count how many companies that can use as modern technology in Vietnam, it's going to be just a handful. So it's the using technology in manufacturing industry is more like a risk for big companies in Vietnam, even with our support from government. Because small and medium enterprises, which account for nearly 97% of the total companies in Vietnam, they are reluctant to spending more capital on the advanced technology. In addition, there's also more challenge for companies to apply modern technology. For example, they're going to have to spend their worker to go to, training to use a new system. And of course, that will result in additional expenses for them. Another challenge is when we apply AI, is require big data. And of course, companies can collect from many sources via IoT, but it's going to be a challenge for them to ensure the information quality. So I can have achieved some improvement greatly in using technology, high technology in manufacturing industry. But it's going to take a long time to encourage small and medium company to join these revolutions. So that is, thank you for listening.
To hear from Vietnam. Now we're going to move over to one of my colleagues here at China Daily Asia Pacific, Miss Grace Chai. Miss Grace Chai has about 9 years of experience as a reporter at China Daily Asia Pacific. She covers mainland financial and technology news, as well as many technology corporation activities between China and Asia. From reading her stories, we know that she has witnessed the intelligent upgrading of mainland manufacturing industries, as she visited and reported many well-known manufacturers and AI leaders here. Grace, are you in Shenzhen or in Hong Kong right now? Can you hear me, Grace?
Hi, DJ, can you hear me?
Yes, we can hear you. It's a little bit of interference from somewhere. Anyway, let's hear your story.
Hi, everyone. To your question, I'll be based in Shenzhen right now. Thank you very much for your introduction. I'm very happy to be here today. Yeah, so today I want to talk about AI talents in the manufacturing industry. As a journalist, I want to start with a simple question. If you have a doctorate degree of computer science in a prestigious university, would you want to work in a factory? I ask this question because once I interviewed such a highly educated AI professional, and the venue of the interview was a welding workshop. You know, we were put two metals together by heating and pressing. So because at that time, he was learning how to weld from the workers every day. In the beginning, the entrepreneur had planned to find some experienced welders who knew about AI to some degree, but he failed. So he had to learn the technique himself. so that he could translate these manufacturer jargons and workers' accumulated experiences into codes and algorithms. But I found actually not so many AI talents with high degrees are willing to devote themselves to the manufacturing sectors. Meanwhile, technicians from vocational schools or ordinary workers usually do not learn much about advanced technology. Besides, looking at the overall market compared with government, internet, and finance industries, I found manufacturing industry is now the major part of China's total AI market. I think we should encourage more AI talents to the manufacturing industry and develop new training models for the high degree talents and as well as average workers in the field. Local markets in China have been implementing innovation-driven development strategies and building smart cities and smart factories. For example, Tianjin aims to become a national advanced manufacturing research and development base by the end of the 14th 12-year plan period, and making every effort to build a national pilot zone of the new generation AI innovations, as Dr. Wang Yu has mentioned just now. To provide high-end talents for the mission, local universities have already taken effective actions. I have learned about 6 higher educational institutions in the city have set up dedicated colleges of artificial intelligence. But as an emerging field, it does not have much educational and teaching methods in the mainland to learn from. Some colleges created a cooperation model linking schools and enterprises and weave this cooperation into the teaching structure and curriculum design. So I believe they are on the right track of providing what the market really needs. They are also striving to attract more AI experts from around the world. The trend presents a golden opportunity for AI experts from all around the world, and especially for research and educational institutions and companies in Hong Kong, as well as those in Asian cities. They could team up with Tianjin and other mainland cities together so they could tap the market and achieve a win-win outcome. Okay, thank you. Thank you for listening. Back to you, DJ.
Thank you, Grace. Okay, we're going to move over to our last panelist, Dr. Umar Saif. In Pakistan, Dr. Saif is the founder and CEO of surveyauto.com. He works as the Chief Digital Officer of the Zhang Jiao Group and the Chief Investment Officer of Kundi Ventures, an investment fund set up to support mid-stage startups in Pakistan. He's also an advisor to the United Nations Development Programme, the UNDP in Pakistan. Great to have you here, Dr. Saif. Can we have your thoughts on this subject of the future of artificial intelligence in manufacturing industries?
Thank you for the opportunity to participate in the conference. I really enjoyed the comments made by all the speakers. Let me start out with an anecdote. I did my PhD in computer science about 20 years ago. This was from Cambridge in England. And the AI folks used to be on a different floor, actually in a different building. Then I went to MIT, where I used to teach for several years in the US. And the AI labs used to be on different floors of the same building. So I was part of the Laboratory for Computer Science, LCS as it was called, whereas the Laboratory for AI was on different floors. And the reason I'm saying this is because about 20 years ago, when I was still a grad student and then a fledgling researcher after that, AI was a pie in the sky. A lot of people wouldn't even believe that AI would come this far. In fact, they had struggled for many, many years wanting to solve some fundamental problems, but didn't get quite far. It was only in the last 5 to 7 years that AI has really come of age and is finding applications in a whole gambit of in a whole gambit of services, from financial services to manufacturing to supply chain, etc., etc. So it's great to see AI coming this far. I happen to be in Pakistan right now. Now, of course, in countries like Pakistan, there's a huge labor arbitrage. So a lot of industry, traditional industry like textile or agriculture-based industry is still very manual. There is very little technology, very little IoT, very little data being collected or AI being applied. However, the company that I started is actually focused on emerging markets. And I want to give that example as a tangible example of what's going on in use of AI. So even though the manufacturing doesn't quite collect as much data or does not use that data for raising alerts and predictive maintenance of machinery or identifying bottlenecks in production, or optimizing processes in warehousing or management of inventory, which is what essentially AI is able to do for the manufacturing industry. What it also struggles with is demand forecasts. So in a large part of the world, like Pakistan and other such markets, the markets are so fragmented because of these mom and pop shops. There are no large chains, so there's very little data. There's no POS scanning. If you buy something, there is no point of sale device that would scan your, what you've bought and would collect that data digitally. So therefore, large companies like the Unilevers and the Procter & Gamble's and the Cokes and the Pepsis and the Philip Morris's, etc., they kind of are flying in the dark. They don't really know, what people are buying in the markets, how much. By the time they get this information, it's already too late because the data is really not collected in hundreds of thousands of these small mom and pop stores where their things are being sold. Now, this data needs to be aggregated somewhere so it can inform their production process. So their entire production and hence the forecasting what they should manufacture and what their production capacity should be and how quickly they should be able to manufacture and supply to potential demand is all based on guesstimates. So the company that I started, I'm going to share my screen here. So the company that I started called Survey Auto does exactly this. So it takes a market, so this is Pakistan, it takes a market like Pakistan, a city like this, and divides this up using AI algorithms based on population, its socioeconomic class, shops, outlets, points of purchases within the city, and then begin to generate demand forecasts for each one of them. So think of this as a city. This is a city of 23 million people. It's the largest city in Pakistan. It happens to have close to 100,000 retail outlets. No one really knows what goes in there, but this platform captures data at every one of these shops and runs these demand forecasting models on how many people live there, what their potential demand could be, how much you could be selling, and how much of that demand you're able to meet. And therefore, what your production process should look like and how efficient your production process needs to be. This is fundamental information for them to be able to do production management. So to give you an example, this is AI at work. We look at satellite imagery. We take satellite imagery. We can tell where there's a more concentration of people. This is population density of a city like Karachi in Pakistan. This is different population clusters within the city. This is various socioeconomic classes within the city. Where do you have rich people living in the city? Where do you have middle class, lower middle class, and then poor people, etc. So what the demand would look like in each one of these little what we call micro trade areas within the city. And once you have the city set up like this, you could see where are you able to meet the demand, where you are behind demand, and what this demand would mean for various manufacturing facilities and the entire supply chain that you're managing in terms of warehouses, distributors, wholesalers, etc. So if I clicked on any one of these, you'll be able to find out how many people live there, how many shops are there, how many of these shops were covered by your products this month, what's the socioeconomic class of that area, how many sales have you done in that area, what's your penetration within that for those 51,000 people, where are those shops that you're selling all these goods to, how many of those shops are actually serviced and not, etc. We do the same in Pakistan, we do the same in Africa. This happens to be Nairobi. Where is Nairobi? This happens to be Nairobi. And Nairobi divided up into population clusters. Now, this is exciting because Africa is different. There are small pockets of clusters in suburban areas as opposed to large cities, metropolitans in countries like India or Pakistan. This is Nairobi's population density. This is generated through machine learning algorithms on satellite imagery analysis. If I were to zoom in, you'll be able to clearly see where most of the people live, and then you see small pockets of population all over. Where would they get their demand? Where do they need to go and supply their goods? What does that demand look like? What do they need to manufacture and how much this month so that they're able to meet this demand? That's fundamental information that they can't generate, and they can't generate it with traditional means. You really need machine learning AI algorithms using satellite imagery analysis, socioeconomic class, average daily consumption of households, and what that might translate into for their production capacity. So this is Nairobi's population density. This is again population divided up into different socioeconomic classes, and this is socioeconomic classes, right? So if you notice, there are sort of little population clusters, right, all over the place. This is Africa. This is how populations are divided up. How many people live here? What do you need to sell them? What are they prepared to buy? And hence, what do you need to manufacture for them? And that seems like, and this is still a larger population. If you zoom in further, you'll see really small population clusters in this polygon. If I were to click on this, let me click on this. If I were to click on this little polygon, you'll see how many people live there. 16,000 people live here. How many shops are there? What are you selling them? How much is your capacity to sell? What's your opportunity to sell? And so on and so forth. So that's just a company that I set up essentially to bridge this gap between large manufacturers of fast-moving product group companies, the Coca-Colas, the Pepsis, the Unilevers, and the Procter & Gambles, and these dark markets that are entirely dark because you know data about them. But AI, machine learning, all these platforms are enabled to analyze all of this and then bring to you all these analytics that help inform your manufacturing product, your manufacturing process, help identify where the bottlenecks might be, and what the demand for next month is going to look like, and is your production set up to be able to meet that demand. I'll stop here.
Thank you very much, Dr. Saif. Now, we have quite a lot of time. Actually, we've got about 45 minutes left for questions and answers. We're asking you to drop your questions into the Zoom chat so we can ask them for you to the panelists. Now, the panelists are made up of everyone here. So everyone who's spoken are joining the panel now to answer the questions. Also, I need to say that if you want more information or more detailed bios on any of our panelists, you'll find that over at the cdroundtable.com website. Now, I'm going to hand over to Kun Panna, my good friend here in, or there, should I say, in Thailand,
Yes.
who's going to take over my moderation and lead the Q&A.
Thank you, DJ, and thank you the panelists for very valuable information. And I think all of us can step in and ask questions. But I like to stay with Dr. Uma for the moment because we are fresh with this information. Who is actually the host of this AI investment? Is it the wholesaler? Is it the big companies that have supply chain, or is it the manufacturer themselves? Who is the host of your service?
So the client for this
the client, correct.
The client is the FMCG. So the companies that work with us are the Unilevers and the Pepsi Colas and the Coca-Colas and the British American Tobacco and Philip Morris and Reckitt Benckiser.
Okay.
Those are the clients for this. And we do this globally now. Vietnam actually is an interesting market for us, Philippines and Indonesia. All these dark markets. Dark markets means that there is very little data coming from the shop floor on which you can base in real time your production forecasting or what you need to produce. So platforms like this, using satellite imagery analysis, capturing data, projecting data, learning from data, doing forecasts, then comes up with data and analysis and insights that informs how much they should produce, where they should supply, is their supply efficient, is their supply chain coping up with demand, what their demand looks like, etc.
And when they apply this to a manufacturer, what are the issues that you see from the manufacturing side? Is it ability to process, or is it a question of the privacy? Privacy means that they may produce for the competitors. Yeah, well, how do they deal with all this?
Well, so it is, so every company gets their, of course, own data, and this is connected to their sales systems and their production capacities, and the platform takes, a slew of data signals in this, from demand to their production capacity, to their supply chain, their warehousing capacity, etc. So it takes all that data in, and every company has their own data sets and their own proprietary data sets and their own ways in which that data is formatted. So the system ingests very, very large amounts of data. Let's say for a company like British American Tobacco in Pakistan, this service could about 400,000 shops. They have like 5 categories. Each category has 5 SKUs. So for every shop, you have to generate a demand forecasting model and aggregate that so that they're able to understand at the manufacturing level what they need to produce next month, given all the sales cycles, the weekly cycle and the monthly cycles of demand that change based on weather, based on people have more salary beginning of the month, less salary at the end of the month, people shop more on weekends versus weekdays. All those cycles in these AI-based forecasting algorithms, they automatically discover these cycles, they're able to decipher these cycles, and based on that analysis, they're able to generate on a weekly basis what their production capacity needs to look like and what their supply chain needs to look like. And once they're able to put this technology in play, we've been able to turn around large companies. So Ricket in Pakistan, they sell Harpic and Dettol, saw a 500 basis points improvement in what they were able to achieve. So this is, they improved their market share by 5% in 6 months. Their monthly revenue went up 50% month on month. And they never faced any stockouts in these shops because they were able to really streamline and align their production based on projected demand from the market, but also pinpoint where that demand might be and which distributor and wholesaler needs to go and service these shops and so on. So the entire sort of process gets digitized. And I emphasize it's easy to do, for Walmart in US because they get digital data from the shop floor. In fact, the company that does this in US, and I'm friends with them, their CTO told me just a few days ago that as soon as someone scans an item that they've bought at Walmart, before that item is put in the car trunk, they get that data. In these dark markets, the Vietnams and the Philippines and the Indonesias and the Pakistans and the Indias and the Africas, there is no such thing. Therefore, the role of AI is even more important to be able to take data, project data, learn from data, decipher data, and forecast based on these data sets.
Okay, thank you. Can I come to Dr. O'Connor, please? You discussed particularly that most of the manufacturing, the SME particularly, are in basically data processing level or move. What scale must you have before you move into more intelligent manufacturing from the experience that you see? It has to be a certain scale to make this worthwhile?
That's a good question. What level? Most of the manufacturers I've been to were SMEs, and what I've found is, for them to scale up, is they're challenged because a lot of them, the owner doesn't want to combine with another factory to make it larger, and you've got legacy mindset issues on that. But what needs to happen in order to actually scale up or digitize and get the data? Any one of these factories that are doing 2,000 units a day of any product can actually collect data that can be used in analytics. And my point is that factory doesn't have to be fully robotized. It can still be labor intensive. It's just a matter of picking strategic parts of the production line to collect more data. And one of the big things that I've seen that lacks the collecting of data is probably in the end of materials receiving. And even when they're collecting data materials receiving, largely it's very paper-based. If they can digitalize that, they can start to get a much richer understanding of, are the materials fit for assembly before it works out into quality defects. So I would focus on just small pockets of collecting data in certain areas, materials receiving, certain quality gates during the production line. What scale? 2,000, you're doing 2,000 units more a day, then that's enough scale to start collecting this data.
And who should be training all these manufacturing staff? Is it the software provider, or is it specialists, or who you think is most appropriate to train them?
I can tell you the university students coming in to learn about the actual documentation of the process, collaborate with local universities and that are doing undergraduate majors in engineering degrees, whether it's materials management degree or electronics, any one of those. Grab those engineering students, give them an opportunity to come into the factory to do an internship or even to do a project. There's, you know, we're talking about 5 million students, undergraduate students in China. Okay, a large portion of them are doing engineering majors. So
okay,
reach out to them.
That's a good point.
It's collaborative. It's already there. You don't have to pay a McKinsey or a BCG to come in and revolutionize your factory.
Yeah.
Start measuring.
Can I go to Dr. Wang? We have heard from the Dr. Nakamura presentation about the deep learning and deep thinking. Can you elaborate more between the two, and how do you see the deep thinking, which he said doesn't depend on the past data, but on mind filter prediction? Can you perhaps elaborate that further, because he is not here? You can help. Thank you.
Yeah, okay. So I think the deep thinking is a very, very good and new concept. But first, we can talk about the deep learning, because it is very, very popular and is a buzzword here. Deep learning often use the past data and to extract the relation inside the data. And we can call this relation as a knowledge, and we use such knowledge to predict like future data and for our applications. And this is what is cited by Nakamura, Dr. Nakamura, is deep learning. In my perspective of view, the deep thinking is not only use such relation, but also use some intrinsic, I think, logic or the reason or the reasonable, like, I think we can call the reasonable relation.
In Tianjin itself, where a lot of manufacturing, which sector is the most use AI the most in deploying AI? Aside from automotive, this is obvious. What other manufacturing that you see a heavy user of this intelligence?
Okay. So as you said, manufacturers have pay attention to intelligent manufacturing, but I think maybe most of them cannot call intelligence. But I know one bicycle manufacturing company. It is called Flying Pigeon. And this company is very, I think, relatively is very. They make the first step towards the intelligence, and let's see some specific content, because you know a bicycle is very complex. It consists of thousands of parts to assemble. But I think in a decade ago or like in 1990s, it maybe take several hours to produce a bicycle. So it's very unacceptable in nowadays, because it's too slow. And 10 years ago, or maybe 8 years ago, the Flying Pigeon company they transform their manufacturing to intelligent manufacturing, some devices. And what they can do is to produce a bicycle in 15 to 17 seconds. So that's a huge step, right? So in this way, they can produce, I think maybe the most of the bicycles in Tianjin, and for some sharing economy platforms to produce service for most Chinese citizens. And I think this is a very good example for intelligent manufacturing.
Okay, thank you. Grace, may I come to Grace? In your coverage of various businesses and visit to factory, which were the company that impressed you most in the use of technology in the manufacturing sector that you visited?
Yeah, thank you for your question, Hannah. Yeah, I visited many factories in.
I think your sound, the sounds of some sound problem.
There's some noise, right?
Yes.
Is it better?
I think we're going to have to live with it. I think we have to live with it, Panna.
Yeah. Okay. Speak a little bit louder.
Yeah, sorry about the noise. Back to your question. I have been to several factories. There are very large factories here in Guangdong, as you know, like Huawei, BRD, and Foxconn. But what intrigues me recently is now these big names, big factories, but small and medium-sized factories. This is the trend of industrial cloud. As I have learned that AI technology is not one industry, it could influence and impact all industries, and especially those small suppliers of those big companies. So I visited some suppliers recently, and they are all connected to the industrial cloud. One supplier I visited is work for China's leading home appliance maker, Media. So Media helps its suppliers to do this intelligent transforming by taking them up to the Media cloud platform. I interviewed one of its suppliers once, and I remember the manager said they don't need to prepare much in stock now, because they could adjust production volume flexibly according to Media's selling records, which are available on this cloud. So the topic of industrial cloud has been going for some time now, but it's really becoming a real deal. I think it's going to influence more factories and industries in the future.
Can I ask this industrial cloud service? Is it a package like Microsoft software that different factory can use, or they're different in content?
Sorry, Hannah, I didn't hear you just now.
Yes, okay. The cloud services that the factory use that you mentioned, are these like software packages like Microsoft software, like Java software? Is it package? You can just buy them off the cloud, or they have to be tailor-made for the manufacturers? Can you hear?
Yes. The factory I went to is actually the cloud is provided by the home appliance maker Media. It's a very famous company here in Guangdong, and they tailor-made this platform actually for Media, and Media help its suppliers to use this platform, and its suppliers can upload their data and the data in inventory to this cloud.
Okay, I understand. Okay, can I go to Lily, please, in Vietnam? Can I ask you, Vietnam is now hosting a lot of new investment. What we mean would that you will be able to start with the latest technology. you don't have many legacy manufacturers that have to reinvent themselves. Do you see this, the new investor applying automation immediately and so on into the production?
Actually, Vietnam's market is really prominent for many investors right now, because we are also, the government also lay out for some support policy for the foreign investment, and also some companies, big company, for example, VinFast, and also like maybe you not heard before, but they are Phonica Group. They are the big company that invest in technology, high technology, and according to them, there are many big company that's foreign company that want to invest and cooperate with them. Like for example, like VinFast will work with Foxconn, for example, and like in the late of March, I attend the introduction of Phonica Group about the Vietnamese first self-less driving car. That that's I was quite impressed with that technology, because that was the first time that Vietnam is the first Vietnamese made the self-less driving car. And also at the presentation, I also heard some representative from Japan and like Honda and some other experts of the university. They mentioned about how Vietnam will develop the techniques, the technology in the future, and how to work on with us. And I think that is a very huge improvement, because Vietnam for a long time we are famous for the cheap labor market. So most of the people will have the concept that when we come to Vietnam, we just high cheap labor and labor intense in the factory. But now it's different, because we also focus on improving using technology in industry. Lately, I also have a chance to talk with the Association of Leather Footwear and Handbag, and she also mentioned to me about that because of COVID, the number of workers can go to the factory decrease, and because when they come back home due to COVID, they don't have the intent to come back to the factory anymore because of the uncertainty. So she told me that the factory that's still open at this moment, they will have to improve. They will have to switch to the technology to replace for the number of lost workers. So I think it's also the big improvement. However, as I was mentioned before, is still a challenge for many small and medium companies. That's because COVID is difficult. They have lost capital, they have lost customer, and the number of sales, their sale is reduced. So it's really hard for them to apply new technology at this moment. Yeah.
Thank you. DJ, I have more questions, but I think you have 3 on the chat list. Why didn't you go with yours? And then
I do have some that have come in on the chat list.
Yeah, go ahead.
So I think we are going to stick with you for now, Panna, because when we edit this and send it out, I think they want to keep it in order. So if you want to go ahead with yours, you've still got another 15 minutes before.
Okay, I go ahead. Can I come back to Dr. O'Connor? I haven't asked you or asked anyone yet about the job impacts. in your visit to the factory, the increased use of automation are related to the job, is that job impacts in this, or you don't, how do you see this? You need to unmute.
I think your microphone's off at the moment, Neil.
Yep.
That's a very good question, job impact. Everyone thinks about that, like robots replacing people. Well, even in the top companies around the world, in the factories that are leading automation, you've got cobots, that is people working with robots that do not strictly work with algorithms, but have some leeway in them in case a person bumps into the robot and things like that. So, you know, there's a sense of that assembly lines still need to have people in particular industries. Getting back to Asia and China, like United Nations predicted over 6 years ago that there'll be 40 million less manufacturing workers in China in the next 10 years. So, you know, the actual supply of labor is naturally going down anyway in the region. So, you know, but that beside the point. Okay, you still need people. I think a lot of factories are not at a stage where they're going to replace people with robots. They've got to replace the manual collection of data on their processes and replace it with a digital copy. When I visited HTC's factory, this was over 8 years ago, even in Taiwan, they were automating some parts of the assembly line. They did not automate the actual assembly of the smartphone. They automated the actual testing element of the smartphone. And so even when companies are automating different stages of the assembly line, it's not like you just replace a whole assembly line with robots. You automate strategically. So for example, the testing area of the assembly line, not the assembly itself.
Okay. Dr. Uma, could I come to you, or in your overview of your global reach in the manufacturing? You talk about the demand supply already, that helps with the production predictions and so on. But in the factory themselves, what else do they use in terms of AI or technology that you see most across the world that you have experienced?
That's a great question. Now, a lot of people, so I think there were several attempts in this conversation in trying to classify AI and what it may or may not be able to do. Of course, you know, there's discussion on whether making your factory floor more automated, is that AI? But that's been going on for a long time. So do you have robotic processes within your assembly lines? Do you automate your assembly lines in ways? Is that AI? I'm not sure. Is using like a control system, like a SCADA system that self-actuates, turns things on and off automatically. Is that AI? I'm not sure. Is using sensors to collect data about various processes or what happens on the shop floor. Is that AI? I'm not sure. What AI can do, however, and that's what I was alluding to as the last 5 to 6 years, that's when AI has become real with machine learning, deep learning, predictive analytics, and so on and so forth. And that's happened because, one, data became available because of everything that I just explained. There were more and more sensors in the manufacturing process. There was more and more opportunity to gather data at every step. And there was sort of more interest in collecting data that is already annotated and classified, and hence in a way that you could process it and analyze it. And as Dr. Neil, I'm sure that's how you pronounce your name. It's as he was referring to, every step of the manufacturing process needs to be digitally documented. So that's the precursor to even before you start to think of something like an AI. So you need data at every step. You need automated capture of data through sensors. You need a lot of your processes documented and data captured, and then you need large teams that annotate this data such that it can be ingested in large data systems which are then able to reason about it. And that, I think, would classify into an AI system. So typical examples or applications of AI are predictive maintenance. When is your next machine going to come up for a maintenance cycle? Not because the manual said so, but because you've been monitoring the operations of this machine, its output, and what the cost of maintenance of this machine look like. So predictive maintenance is typically the first application. Then there is elements of identifying hotspots or bottlenecks within your manufacturing process. Because you're collecting all this data, you can then classify that this specific machine or a process or part of the assembly line is what's holding up or causing a bottleneck in the manufacturing process. 2, 3, productivity of workers on the factory floor. So if you have enough cameras and sensors and so on, you can identify which parts are seeing more activity. Is the floor plan laid out perfectly? Are there areas that become bottlenecks? Can easily move on the factory floor? Which areas become hotspots of activity and hence bottlenecks in the production process? Which areas hold up the manufacturing process? That's the third part. The fourth part that's even more exciting is then being able to use these analytics to improve your product. So there was discussion on an application in quality assurance. So whatever comes out of your factory as a product, of course, there are many ways to test it, but machine learning, AI, deep learning, sort of this, what has happened in the last 5 to 6 years, can test your product, not because of a manual that you can read and it must conform to certain standards in that manual, but because what you learned from what a successful product looked like. So for using a wealth of data, which is laid out, annotated, classified in all the right ways, these machine learning algorithms can learn behavior. They can learn when a machine typically breaks down or is about to break down. So predictive maintenance. They can learn what processes typically begin to look like bottlenecks because they've seen this behavior before. They can learn what a successful product that crosses a certain threshold of quality looks like. That, for me, is an application of AI, which is using historical data to train systems so that they can then predictively learn and anticipate and raise alerts before certain events happen. That is, for me, is AI. And data and sensors and SCADA systems, etc., are all enablements of an AI system like this.
Okay, thank you for clarification. Very helpful. Can I come to both Grace and Dr. Wang? We have heard a lot about China becoming the world's leader in AI. What does it mean? What does it mean? Means that what is the leadership in AI? Is it scientific research, or is it ability to manipulate, understand data? Is it a consumer society that embraces automation? What does it mean in your view from China, within China? Either of you. Yes. What does it mean? Yeah, go ahead.
Okay. I go first. That's a very big and a very good question. And from my perspective view, because I'm a researcher, and in terms of researches, I don't think the China is ranking first, because although we have many patent applications, papers published, but actually we have a relative, I think it's a relative weak basic for artificial intelligence researchers, because most of our researches are in my point of view, is incrementally changed, because in fact, in the real world applications, what we commonly use is also the the SVM, support vector machine, and the linear regression, logistic regression, and these models, I think are maybe 20 years ago, but they perform the best. What this means is that the new algorithms, the new models designed by the researchers maybe applied to some specific scenarios, but for like some complex ones, such as the manufacturing, we still have a long way to go. So in terms of researchers, I think China maybe not the first one, but the advantage of China is the market. We have the big market. We have various market applications, such as like finance and hospital, education, and manufacturing. We have a lot of people. So that means we have a massive consumers to help us to promote the AI researches. So that's my point of view. So we hope, and I hope that we can go further in terms of the researches, and such researches can help the development of various applications.
Thank you very much to all of our panelists. This has been a fascinating discussion, as ever. Now, some of this will be summed up on some of the China Daily platforms later today. So if you want to revisit it, you will find it on the China Daily Facebook, and I'm sure on their websites as well. For now, thank you, Panna, also for co-moderating with me. But for today, this is the end of the session. And again, thank you very much to all our panelists. Goodbye from me in Hong Kong and from the rest of us. Bye-bye.
Thank you. Bye. Bye.